Have you ever pondered about the invisible forces that constantly blow from the sun and affect our planet? This is not some mystical force, but a scientific phenomenon known as the solar wind. Imagine this: a stream of charged particles bursting from the upper atmosphere of our very own star, the sun, and hurtling through the cosmos. But don't be fooled by the term wind. This isn't your everyday breeze rustling the leaves on trees. No, this is a gust of particles and magnetic fields, a cosmic tempest that never ceases. Emanating from the sun's corona, these particles are so energetic, so heated, that they escape the sun's mighty gravitational pull and venture out into the vast expanse of space. This continuously flowing solar wind stretches far out into space, forming a vast solar bubble known as the heliosphere. A cosmic puzzle indeed, and one that we're just beginning to piece together. But where does this solar wind originate? How does it manage to travel such vast distances? These are questions that have puzzled scientists and space enthusiasts alike for decades. Our journey begins with the sun, the star at the center of our solar system and the primary source of the solar wind. The sun, like all stars, is a hot ball of gases. Its outermost layer is known as the corona, a region of extremely high temperatures, reaching up to a few million degrees Celsius. This intense heat is the cradle of the solar wind. The extreme temperatures of the sun's corona cause hydrogen atoms to split into protons and electrons, creating a plasma state. This high-energy plasma is constantly in motion, creating an ever-changing environment. But how does this plasma escape the sun's gravitational pull to form the solar wind? The answer lies in the sun's immense heat. The sun's corona is so hot that it imparts a great deal of kinetic energy to these charged particles. This kinetic energy is so high that it overcomes the sun's gravitational pull. As a result, these particles are accelerated and blown out into space, forming the solar wind. However, the solar wind is not a constant stream. It varies in speed and density, influenced by the activity on the sun's surface. During periods of high solar activity, such as solar flares or coronal mass ejections, the solar wind can become more intense. This variability adds another layer of complexity to our understanding of the solar wind. Despite the vast distances involved, the solar wind travels at an incredible speed, reaching Earth in just a few days. This is due to the immense energy imparted to the particles by the sun's corona. The solar wind, once launched, continues its journey through the solar system, carrying with it the influence of the sun. And so, these charged particles embark on an interstellar journey, affecting everything in their path. The solar wind, a fascinating phenomenon born from the sun's intense heat and the kinetic energy of charged particles, continues to intrigue and inspire us as we delve deeper into the mysteries of our universe. You might be wondering, does this solar wind affect Earth? What happens when these charged particles reach our planet? Well, let's dive into that. The Earth, in its own right, is a celestial body of wonder. One of its many marvels is the magnetic field that surrounds it. This magnetic field, invisible to the naked eye, behaves much like a shield, protecting our planet from the constant onslaught of solar wind. Now, this isn't your average gust of wind, but a stream of charged particles, mainly electrons and protons, hurled towards us at speeds of 1,000,000 miles per hour. Think of Earth's magnetic field as an invisible force field stretching thousands of miles into space. When the solar wind encounters this force field, it is deflected, prevented from directly impacting our planet's surface. This keeps us safe from the harmful effects of these high-energy particles which, if they were to reach our surface, could cause severe damage to life and technology. However, not all particles are deflected. Some of them manage to sneak past this protective shield, especially near the poles. When they do, they interact with the gases in our atmosphere, causing them to light up. This results in one of the most breathtaking natural phenomena we know, the auroras. Auroras, also known as the northern and southern lights, are a direct result of this cosmic interaction. Charged particles from the solar wind stimulate oxygen and nitrogen in our atmosphere. The result is a dazzling light show with curtains of green, red, yellow, and even purple light dancing across the sky. So while the solar wind is a powerful force, our planet's magnetic field acts as a protective shield, turning potential harm into a beautiful spectacle. The Earth, in its cosmic ballet with the sun, transforms the solar wind's threat into a visual symphony that leaves us in awe. It's a reminder of our planet's inherent resilience and a testament to the wonders of the universe. The solar wind's journey doesn't stop at Earth. How far does it reach, and why should we study it? The answers to these questions might surprise you. The solar wind, a sizzling stream of charged particles, paints a grand cosmic canvas, extending far beyond the planets, stretching to the edges of our solar system. This invisible force field, known as the heliosphere, defines the boundaries of our celestial neighborhood. It's like the sun's own signature, a unique identifier in the vast expanse of the universe. Now, you may wonder, why should we study the solar wind? The answer lies in the concept of space weather. Just as we have weather patterns on Earth, space too has its own climatic system largely driven by the solar wind. Space weather is more than just a scientific curiosity. It has real-world implications, especially for our increasingly technology-dependent society. The solar wind, with its magnetic disturbances, can affect satellite communications, GPS systems, and even power grids on Earth. Moreover, understanding the solar wind is crucial for the safety of astronauts and spacecraft venturing into the cosmos. The solar wind can cause wear and tear on spacecraft over time, and intense solar windstorms can even pose a radiation risk to astronauts. In recent years, scientists have launched missions to study the solar wind up close. These studies help us predict space weather, protect our technology, and ensure the safety of our space explorers. The solar wind is a testament to the sun's far-reaching influence. Even from millions of miles away, it shapes our space environment, affects our technology, and challenges our understanding of the universe. As we continue to push the boundaries of exploration, peering into the farthest corners of the cosmos and venturing into the unknown, the solar wind remains a constant companion. It's a reminder of our interconnectedness with the universe, a thread that weaves us into the cosmic fabric. As we continue to explore the cosmos, understanding the solar wind will remain an integral part of our journey.
Please do like, share and subscribe to my channel.